All right, guys. So today we are going to be looking at the topic. We're still on the topic of algebra. We're just going to go into a little bit more details. And today we're looking at simplifying algebraic expressions. Now, we have the word here, expression. Now, as we move along, we'll be defining what we mean by expression, terms, and so on, because oftentimes students not understanding fully what the definitions of these terms are sometimes confuse them. All right, so it is important for us to have a good grasp of what these terms really mean. All right, so at closer to the end of this session, or pretty much at the end of the session, we'll have a discussion based on the SBA progress. I would like to address some issues that I see coming out from the SBAs, all right? All right, so moving along, simplifying algebraic expression. So let us talk a little bit about these words. Anybody knows what you mean by simplifying, what it means to simplify? This way some.
Sir, to further break down into its lowest term.
Right. Or in other words, you know, to make it simpler, as simple as possible. All right. Algebraic expression. Miss Amanda, what do you understand about algebraic expression? Are you there, Miss Amanda?
Yes, sir.
Anything you can say about algebraic expression? Still thinking about it? All right,
Yes, sir.
Miss Trivia. Miss Trivia, algebraic expression, what comes to your mind?
Sir, I will think about expressing a question in using letter to replace numbers.
All right. All right, using letters to replace numbers. I think you have an idea of what you think an expression is, but to be a little bit clearer than just that, there are some things that we'll be looking at shortly from now. I'd rather to go through the definition before I give you a full understanding of what we mean by expression. So we want to start off looking at terms, and here we're looking at expression. Now, if you look at the column on the left, and you look at the column on the right, what difference you notice with the column on the left and the column on the right? What is the difference between terms and expression? Let me ask somebody now. Miss Green, based on what you're seeing in the table, how would you differentiate between terms and expressions? Miss Green, are you there?
Yes, sir.
So based on what you're seeing in the table, what do you think? Okay. All right. Anybody would like to try, raise your hand. Let me see somebody who think they are able to explain the difference. Go ahead, Miss Williams.
Sir, I am only going to try. When you look at the terms, these terms stand by themselves, but the expression, there is an operation being used with the expression.
All right. Miss Waysome, would you like to say anything about?
Sir, I was just about to say the same thing, because looking at term, you might have numbers and variables, but in expression, you have numbers and variables used in an expression. So I was basically saying the same thing.
All right, Ms. Williams would have said something about the expressions of operation between them. But if you look at the terms, do we have any operations between terms?
Yes, sir. It seems so to me as well. Because the 2x would have been 2 times x, and the a be a times b.
All right, so clearly with the terms, you do have operation, but you notice that for the terms, the operations are limited to what? Multiplication and
Division.
division. So for terms, you can have products, you can have quotients, and products are when you multiply a group of elements together, a group of, in this case, numbers and letters. Quotient is when you divide one term by another, one letter by another. So what you notice with term, you can have a single letter by itself as a term. You can have a number times a letter. You can have a letter times another letter. You can have a letter divided by a letter. You can also have letter divided by numbers and so on. But the key element for term is that you can find the products of letters and numbers, and you can find the quotient. So these by themselves are referred to as terms. Whereas in expression now, what you notice with expression is that you will see plus and minus between terms, right? So for expressions, you may have terms being added or subtracted. All right, so that's the chief difference between terms and expression. So we're going to dig a little deeper and see why we really call them, why do we just have them as an expression? All right, so symbols, letters are general statements and are unknown until they are assigned a value. Now, when you have a number group with a letter or a number in front, any letter, a letter with no number in front of it, no obvious number in front of it. So when you have a number in front of a letter, that number in front of the letter is called coefficient. Right? So any number you have in front, any letter, it is called a coefficient. Now, there are times when you have letters where you don't see any obvious number in front of the letters. But we must also realize that we can have 1 times a number, 1 times a letter will give you back the same letter. So in that case, where you have just a letter by itself, we have to imagine that there's always a 1 in front of it. Even if we are not seeing the 1, there's always a 1 there. Owing to the fact that if you multiply 1 times that letter, you'll get back the letter. That means we can always say there's a coefficient of 1. All right. Now, when you look at these two situations, this term here has a number, and the coefficient here will be what? Or to the coefficient on this side. Miss Green, what's the coefficient here? Are you there, Miss Green?
Yes, sir.
So what's the coefficient for this term here?
Is it the X, sir?
No, apparently you weren't hearing me or you weren't listening to what I was saying.
Sir, 2.
Yes. So the number in front of the letter is the coefficient. So here, the 2 here is the coefficient of this letter. All right, so in other words, we say the coefficient of x here is 2. Now, if you look at this x by itself, and we ask, what is the coefficient? Then you might be tempted to say that there is no coefficient because there is no obvious number in front, the x. But for this situation, we always take it that there's an invisible one there. So in other words, every unknown where there is no letter in front of them has a coefficient of 1, right? Now, this is often confused by students who, if you ask them what the value of x is, they generally tell you that the value of x is 1. Now, remember, you can't say x is 1 because you don't know what value x is unless you assign it some value. So x is not 1. What they probably meant to say is that the coefficient of x is 1. That means the number in front of x is 1. So I hope you guys get the idea, because oftentimes I heard students say that if you ask them, what's the value of x? They say it is 1, but that's not correct. So here we can say that the coefficient of x is 1. Not the value of x. All right, so here, coefficient, and the x would be the unknown. Here the x is unknown, and then now you have 1, which is invisible, and so that is the coefficient. All right, now we also talk about like terms and unlike terms. Now, when you look at all of these 3 terms, can we say that these 3 terms are the same? Anybody?
No, sir.
All right, let's weigh some. What would you say, what would you use to distinguish whether or not the terms are alike or they're different?
Sir, they're variable.
All
We have x and y variables. So the 2x and 3x would have been like term, but for the 2y, no, sir, unlike.
All right, so any term that have the same x variable, I wouldn't say x variable because the variable can come in any letter. Any terms that have the same variable, meaning that they have the same letters, right? Once they have the same letters, and to be a little bit more specific, if they have the same product of in terms of letters, or if they have the same term. So if you have the coefficient and you have the terms are the same. Because if we go back to our first table, when we look at terms, we see that a term can be the product of 2 letters. So if you have terms that either a single letter by itself or a product or a quotient that are the same, we call those like terms. So the key thing is that what we have here in terms of the unknowns, if they are the same, we're not looking at the coefficient now. If the unknowns are the same, we say that they are like terms. If the unknowns are different, we say that they are unlike terms. So here, these are like terms. Here, these are unlike terms. All right. Now, these are terms that have what? Different letters or different variables. So the unlike terms have different variables and the like terms have the same variables. All right. Now, when you look at these three letters here, now what do you notice about these three terms? Can we identify any like terms here?
Yes, sir.
All right, what are the like terms?
2x and 3x.
Okay, what are the unlike terms?
2x squared.
All right, can we see why this would not be the same as
It has an exponent, unlike the others.
exponent? Now, the exponent here indicates what?
The power raised to.
All right, so here x would raise to the power 2. So in other words, if you think about this, you would have 2 times x times x. So in other words, this term is the product of x. And so this is a product, but this is not a product. This is a single x. And because this is a product, this becomes a different term. So if these have the same terms, they would be, if these two letters are these two terms have x times x in them, then they would have the same term, right? So we see that once the unknown are the same and the powers are different, they are no longer like terms. So that is one thing that you should be careful about, because sometimes students will look at terms because the letters are the same, but they're not paying attention to the power, and they will classify them as like terms, but they are not like terms once the power is different. All right, so that's another example. So same variable, but different power. Now look at these terms. What we notice here. Any like terms?
Yes, sir.
Okay. So we notice that this is still a like term because they have the same variable x. But this one would be unlike term. Why would this one be unlike term?
It have a capital X.
Right, so even though they have the same variable x, one is an uppercase letter, meaning one is a capital letter, and one is a lowercase letter, which is a common letter. Once the case are different, they are no longer like term, right? Same variable, but the cases are different. All right. Now, expressions are formed from the addition and subtraction of unlike terms. What we say form from addition and subtraction of unlike terms?
Expressions, sir.
Expressions. All right, so in other words, how we really combine expressions is when we are trying to add terms that are unlike. Now, we can add like terms in a certain way, but we can add unlike terms. But when we add unlike terms, we get expression. When we add like terms, we get a simplified form of the same term. All right, so what do I mean by that? Now, addition and subtraction of algebraic terms. Like terms are numerical multiple of the same algebraic quantity. Now, when we say they are numerical multiple of the same algebraic quantity, all we are saying is that you have the same variable, but the coefficient can be different, right? Because it is a coefficient which is which now multiplies the term. That's why we say numerical multiple, because once you're multiplying by a number, a numerical multiple, meaning that you can have different coefficients of the same term, and they would be multiples of the same term, right? So here we have, for instance, we have the term x. But here now we have 7 times x. Now 7 times x is a multiple of x. Here we have 5x. 5 times x is also a multiple of x. Then we have what? Minus 3x. So here we have a multiple of x. So we say that like terms are numerical multiples of the same algebraic quantity. The same algebraic quantity here has to do with the x. All of them has the algebraic quantity x, because this is the quantity of the unknown. But the coefficient tell you the multiple of x for this term. The coefficient here tell you the multiple for x of this term. And so because they're just multiple of the same algebraic term or the same unknown, or if you want to say the same variable, because they're just numeric multiple of the same variable, we say that the terms are like terms. Because once the variable x here is the same for all of them, then they are like terms. So that's just another way of, or another different perspective of like terms. All right, now in adding terms, only like terms can be added or subtracted. Well, when we say only like terms can be added or subtracted, what it really means is that only like terms can be simplified when added or subtracted. So in other words, unlike term when added or subtracted, they don't simplify into a single term. Like terms, when you add them or subtract them, they simplify into a single term. Now, it means that when you add like terms, you don't get expressions because it's simplified into a single term. But if you have unlike terms, because they don't have them simplified to a single term, that means they will form expressions. All right, and if you just recall, expressions are when you have terms where you have plus or minus sign between them, those form into an expression. And you will notice that every expression that you notice is that they don't have any like terms in them. They are all unlike terms, and that's why it remains as is, as an expression. So when we're adding terms, if they are like terms, we simplify them by adding them or subtracting them to a single term, right? And rule 2, we add like terms by adding their coefficients, all right? Now, all of this may sound a little weird when you use all of these terminology, but you will realize that the coefficient there is just telling you how much of that term that you have. So if you're thinking in terms of, say, fruits, right? And let's say that the A here is apple, the B here is banana, and the C here is what? carrot. Then the coefficient here tell you how many A's you have. You have 7 A's. How many bananas? So in other words, you have 7 apples, 3 bananas, and you owe somebody 2 carrots. So what you will notice here, when we are adding these quantities, the same rules that we would have learned when we were looking at integers will also follow when we are adding like terms. So the same principles of negative and positive will follow during adding and subtracting of like terms. All right, so because these terms are unlike terms, when you try to add them, we don't just simply add. You see, if we have 7 apples and we have 6 more apples, we can now say that we have in total 7 apples plus 6 apples would give you in total 13 apples. And then that would have simplified into a single term, which is 13A. However, if we have 7 apples and 7 bananas and 2 carrots, we can't add these together to get a simplified term because apples and bananas are not the same. So we can add 7 apples plus 3 bananas and call it 10 apple bananas. It doesn't work like that. It's either you have 7 apples, 3 bananas, and carrots. So because they are not the same algebraic quantity, or they are not the same variable, they are not the same unknowns, then when you add them in expression, when you add them, the unlike unknowns or the unlike terms, you keep the plus sign and the minus sign between them to say, yes, we are adding them, but we are not adding them as a single like term that will simplify into a single term. We are adding them as we have 7 apples, we have 3 bananas, and we owe somebody 2 carrots. Let me see your hands if you understand clearly what I'm saying about like terms and unlike terms. All right, is there anybody who's not very clear as to what I'm saying and need me to clarify anything? Raise your hand if you
Sir,
Yeah, go ahead, Mr.
for the unlike terms, you would just leave it as it remains.
Right,
As it is.
right. So we leave them as they are. Since there is no other term like them to add them to, we just leave them as they are, keep the plus sign and minus sign between the unlike terms, and the entire thing now becomes what we call an expression. So because this cannot be simplified into a term, and because it consists of different terms, we're still going to treat this, we're going to treat all of it as a single thing that we add, you know. But the single thing that we add did not simplify into a term. It now becomes an expression. You get the idea? So an expression is also treated as a single term, but it is not simplified in a single term. You get what I'm saying? Is that clear to you, Ms. Trevor?
Yes, sir.
Sure. All right, so the key thing then is, one, to be able to differentiate between terms that are alike and terms that are unlike. Now, when you look at this expression here, what you'll notice here, the algebraic quantity, when I refer to algebraic quantity, we're talking about the unknowns. So the unknown part of this term is a squared b. This is the unknown part. The unknown part of